Hello, good morning, everyone. So, I'm going to a lecture of business statistics module 3 on probability distribution. We have a method called as Poisson distribution. So, let us start with it. It is a discrete random variable distribution that expresses probability of the given number of event in a fixed interval of time. It can also be used for a number of events in other specified intervals such as distance, area, or volume. Okay, so this method is used to fix the different probabilities based on the time intervals. Okay, so how to have a distribution? So we have an equation called as the probability functions. It's called as f of x is equal to e raised to minus m into m raised to x whole divided by x factorial. So where m is mean number of success occur in a specified region, x actual number of success that occur in a specified region, and this m is also called as mean, and it can be written as n into p, where n is the number of samples taken and p is the probability of success or failure. Okay, so we'll go to the next slide. So in order to have this Poisson distribution, you should remember these things. So variance sigma square is also equal to m, and standard deviation st is equal to sigma, that is also equal to square of m. And inverse of this standard deviation is called as a skewness, that is 1 by root m. Okay, then kurtosis, peak at this values, that is also a reciprocal of mean or number of successful trials. Okay, suppose they have asked there is a one probability properties. The probability of x less than greater than or equal to some values that can be written as 1 minus p probability of x less than x. So x is less than some value. Okay, so we have, in order to solve the examples, you need to remember this equation. Okay, most important equation for probability function for Poisson distribution is f of x is equal to e raised to minus m mx divided by x factor. Remember that em is the mean of success, anything, any question is success, and x is the actual number of success occur in a process. So let us have some example to understand deeply what is probability function. So we go to the first example, which is observed. If 4% of electric geyser manufactured by a company are defective, use Poisson distribution to find the probability in a sample of 100 geysers. When none is defective, second point is 5 geysers are defective, given that e raised to minus 4 is equal to 0.08. So if you observe and read the question properly, so here he's asking to have a Poisson distribution based on the defective rate. Okay, defection. So what he says that out of 100, 4% of the electric geysers are defective. So question is, what is the probability or Poisson distribution when there is no is defective or 5 geysers are defective? So we have a solution, simple solution. Let's observe here. Let probability of defective geysers is P. In the question it is given as that there is a 4% of products are defective. So that is 0.04. How to calculate the probability? How it is comes at 0.04. So 4% of 100 are defective. So probability of defective product is 0.04. It is given in the percentage, not given in the values. Okay, so 0.04. So if you observe the number of samples are 100 in the question, so again we consider number of samples 100. So question is, what is the probability none of them is defective? So use the Poisson distribution equation. F of x e is equal to minus m of x and x factorial. Okay. Then how to calculate this m and x? X is the actually what is the given in the question. So see the question. None is defective means there is no defection means x is 0, and 5 geysers are defective means x is 5. Now we got the value of x. X is the actual values. So it is given in the question 0 and 5. We need to calculate f of 0 and f of 5 in order to calculate the distribution. that is Poisson's distribution. Yeah. So now how to calculate M? So mean, we have one equation for mean. Mean is equal to N into P, number of observation into probability of this defective results. So when you calculate mean, you will get 4. So now first case, for known is defective, X value is 0 and M is equal to 4 that we have calculated. So if you put X and M equal to X is equal to 0 and M equal to 4 in this above equation, you will get the probability of this for known is defective. Okay, so this is called Poisson's distribution method. Similarly, second bit. What is second bit is there when there is 5 results are effective. Take X as 5, put X is equal to 5 and M equal to 4 in same equation, then you will get the probability of 5 defective cases is 15% of 0.0156. So this is the answer for first example. Now let's go for another example. A mathematical book contains 115 misprint distributed at random throughout its 115 pages. So in a mathematical book, there is 115 misprints in a 115 pages. So what is the probability that the page observed at the random contains at least 3 misprints? Assume Poisson's distribution. So what is this is that on every page you have a 1 misprint. So from this 2 value, we can calculate the mean, that is M value. Then what is the probability that the page observed at random contains at least 3 misprints? This 3 is indicate the value of X. So simple equation we use here. Just observe your solution. Book contains 115 misprints on 115 pages. So mean we can say number of misprints divided by total number of observation. So that is give 1. Okay, now question is find the probability when at least 3 misprints are there in a page. So at least 3, now what is asking? Contains at least 3. At least 3 means there may be 3 or more than 3 misprints already there. So if you take more than 3 means P of 3, P of 4, so it will goes on up to 100, 115. So now we will use a property which I show you on the first page. The probability of X less than or equal to N is, sorry, greater than or equal to N is equal to 1 minus P X less than N. So if you compare this, what is we ask? The probability when at least 3 are more print. Okay, or you have a defect, or at least 3 or more you have a defect. So instead of going more, we can use this formula to calculate less. So if you see 3, minimum 3 is asking. So we can see P of X less than 3. So we can have the formula P of this is, so it is represented by a function F instead of P. So F of X greater than or equal to 3 is equal to 1 minus F of X less than 3. So now F of X less than 3, we can say F of 0, F of 1, and F of 2. This F of 0, F of 1, and F of 2, we can calculate by using a Poisson distribution equation, that is previous one. That's this equation. So here, so F of 1, then X will be 1, F of 0, X will be 0, and F of 2, X will be 2. Okay, and M value is we have calculated by given data. This is an M value. Now put, let us say this equation is written as like this. F of 0. So put M equal to 1. See, M equal to 1 we have calculated. So M equal to 1. Then what we call X is equal to 0. Put in this equation. Then similarly M equal to 1 and X is equal to 1 because F of 1. Then F of 2, X is equal to 2 and M equal to 1. So if you calculate this, so you will get the probability of getting more than 3. So at least, or this question says that why we are calculating, why we are taking more than 3. So as per the question, so what he has, what is the probability that page observed at random contains at least 3 misprint? At least, he's not asked. At least, so there will be a more mistake. Maybe 115, 10. So that's why we have taken this equation. So for this failure to R. So this is our second example for Poisson distribution. Now, very important example for exam point of view. Metro passenger arrive randomly and independently at the passenger screening facility at a metro station. The mean arrival rate is 8 passengers per minute. So see, so mean is given in this question. Mean arrival rate is equal to 8. So M is equal to 8, but it is given in per minute. Now question is compute the probability there is no arrival, means x is equal to 0 and m equal to 8 in 1 minute. Second point, compute the probability that 3 or fewer passengers arrive in a 1 minute. Now similar question, it is maybe 3 or less than 3. This is a question about it. So maybe 3 or less than 3 means you have to use equation of probability, f of 0, f of 1, f of 2, f of 3, like this, so per minute. Now come to the next point here. Third point, you just clearly observe it. Compute the probability of no arrivals in a 15 second. So instead of 1 minute, it is given as a 15 second. The value of m, if you observe, 8 passenger per minute is there. So if you go for the 15 second, you can see in 1 minute, how many 15 seconds? 4 seconds. If you divide this value with the 4, then you will get the m value for this case. So for these two cases, m value is 2. For these two cases, m value is 4. Remember this one. Next, compute the probability of at least one arrival. At least one means more than one is asking. Okay, so now let us go to the solution. So mean arrival rate is given in the question, 8 passenger per minute. That is nothing but the mean, small m. So question 1 is probability of no arrival in a 1 minute. So this mean is given in the minute, so we can take directly. So no arrival means put x is equal to 0 here. So this is actual value and this is a mean value. So put x is equal to 0 in the probability, what we call Poisson distribution equation, you will get the probability of no arrival. Next, probability that 3 or fewer passengers arrive in a 1 minute. 3 or fewer means maybe 3 or more than, less than 3. So just observe x is less than or equal to 3. We can have f of 0, f of 1, f of 2, and f of 3. Have this all values, so you will get probability of this. So here f of 1 means x, you use x value as 1, here x value as 2, and y value, x value as 3 for this case. So practice it. Okay. Next, third point. So probability of no arrival in 15 seconds. Now I told you. So this mean value is given for minute. So in order to convert to the seconds, so this value, so every minute you have a 15 seconds. So divide this one, then you will get m equal to 2. So now question is, what is the probability of no arrival in 15 seconds? So no arrival means x is equal to 0. Put x is equal to 0, but here m will be 2, not 8. Okay, remember that this is 15 seconds. Suppose it is given as 10 seconds. So this value can be divided by, observe that. So 10 seconds means you can divide this with 6. If it is given as 5 seconds, you can divide by 12. Like this, you have to change the value of m. So question can be anytime. Next, third point, probability of at least one arrival in a 15 seconds. So he asked the probabilities of at least one arrival. At least one arrival. So here you can say, so put x is equal to 1. At least he's asking only one arrival. So put x is equal to 1, you will get. But here the value of m is 2 because it is asking for 15 seconds. So this completes this question. I hope it's clear. Now I'll go to the last example, very important for exam point of view. The following table gives the number of days in a 60-second period during which road accident occur in a town. So in a 60 days, how many road accidents occur in a town? So that is given in the question. Fit Poisson distribution to the data. This is the most important question. Previously in examination they have asked. Okay, so just observe here. So number of accidents and number of days. Okay, so now here there is no mean value is given. Now mean value or average value you have to calculate by using a first example or first type or first chapter method called as the mean or arithmetic mean. So this is a discrete series because number of accidents are given and number of days. So number of days indicates number of months, number of everything is called as the frequency. The frequency will be given in the number of days, seconds. Okay, an accident maybe it's considered as x. So now I have taken solution of this example. First of all, you need to calculate the value of mean. Then you have to put the value of x and find out the Poisson distribution data. So just clearly observe all of it. So this is a prepared table. So I have taken as number of accident as x because this is the values, and number of days I have taken as frequency because every day accidents will repeat again and again. Okay, so now this is number of accident and this is number of days. So that is considered as frequency. So sum of f is equal to n, that is equal to 60. This is a discrete method to calculate the mean. So second method of mean. Then f into x. So if you want to calculate mean, you know the remember equation for first chapter. M is equal to sum of fx divided by sum of. So m value you will get here 0.75. Now what is the question? The probability of distribution by using a Poisson's distribution. So you have the value of x 1, 2, 3, 4. So what you need to do, simply by putting x is equal to 0, 1, 2, 3, 4, you need to calculate f values. So I have did here. So first of all, f of 0, then second point f of 1, f of 2, and f of 3, and finally f of 4. So there are 4 values you will get. So here in f of 1 or f of 2, x value will be 1 and m value will be whatever you have calculated, 0.75. So similarly, you have to calculate f1, f2, f3, and f4. By putting all the values, you need to create a one more table. So the Poisson distribution, how can you draw, is by multiplying the frequencies with n. So x value, so the Poisson distribution, by multiplying the frequency with m, you will get the final frequency. So just observe here of 0 into n, the number of observation if you observe in the question. So the total number of observation in the question is 60 days. So it is taken for 60 days or n equal to 60. So this is called fitting a Poisson's distribution. So finally what you need to do, multiply these probabilities to the number of observations n. So you will get this table. So this give the Poisson's distribution for the given data. So this Poisson distribution you use for fixing the data based on the time period. Okay, so for 0 days, so this is 28. For 1 day, it is 21. For 2 days, it is 7.94. For 3 day, 1.99, and 4th day, it is 0.37. So if you observe that these values are slightly reducing every days. Okay, so this complete Poisson's distribution chapter. So if you have any queries, any questions, you can put comments on the channel. Thank you.